All right, good morning, everyone. I hope everyone is staying healthy and finding ways to keep each other busy. As I mentioned yesterday in my Google Classroom, me and Miss McGarry are going to be making little videos that describe the notes to hopefully help you guys understand the notes a little bit better. All of the media apps are being bombarded right now, so just kind of bear with me as I do this with my phone and one-handed. So we're going to talk about balance versus unbalanced forces today. And when we talk about balance versus unbalanced forces, we are focusing mainly on contact forces. Now, just a quick review, remember a force is a push or a pull, and a contact force involves two objects touching, at least two objects, to apply that force, that push or pull, okay? So the first thing I'm going to focus on today is I'm going to talk about balance forces. Balance forces are when all of the forces combine to equal zero. If the forces equal zero, we have no change in movement. That means that the object is perfectly still and it will not move, okay? So there is one little exception to this. Remember that in space, there is no air molecules, no friction. So a balance force in space, let's say something comes and pushes something in space, that object will continue to go forever and ever and ever and ever and ever in that same direction. And that is a balance force as well. The reason for that is because there is no change in movement. This is the big deal with balance forces, no change in movement, okay? Now, the only time that we see this movement forever and ever and ever and ever without stopping is in space. But here on Earth, no change in movement basically means that it's standing completely still, okay? So again, remember, on Earth would mean it's standing still, not going to move. In space might mean that it's moving in the same direction forever and ever and ever. I gave two examples here in the notes, and I went ahead and I drew a little compass here. I always like to start by drawing my compass because I feel like it's more specific than saying left or right, because it all depends, right? Where are you standing? Is it my left or is it your left? So if we use this compass here, it's a lot easier and a lot clearer to focus on which direction we're going in. So the way I always draw my compass is I rely on that little saying, never eat soggy waffles. And I actually say that in my head every single time I draw my compass. When you're doing a quiz or you're answering a question, you should draw your compass at the top of your notes to help you give the direction. Okay? All right, so let's go with the first example here. If we have a present and two people are pulling at the present, this person is pulling in this direction or east with a force of 15 newtons, and this person is pulling in the opposite direction with a force of 15 newtons west, right? These forces are working against each other, but they're also the same size. Now, just a quick review to Miss McGarry's notes, 15 minus 15, we're subtracting them because they're working against each other, is going to equal 0. Because it's equal 0, the net force, we can say that the forces are balanced, and this present will not move. It's going to stay right in the center, okay? That means that the forces are balanced. In a similar example, let's say we have a coffee mug and a person pushes the coffee mug with the force of 10 newtons to the left or west and 10 newtons to the right or east. Notice how both of the forces are the exact same size. And since they're working against each other, again, we're going to subtract them. 10 minus 10 is going to equal 0. Because our net force is 0, we say that the forces are balanced. So when the net force equals 0, the forces are balanced and we're going to have no change in movement. In both of these examples, the present or the coffee mug will not move, okay? This is about the only time where you're not going to need to include direction. So remember how we talked about how force is a vector. It's going to have both size and direction. Size would be like the 15 newtons right here. The direction is the direction that the arrow is pointing in. When the net force is 0, it's not moving, so there's no direction. That's the only time you're not going to include an arrow, okay? So there's a couple exceptions to this balance force. Let's review. Balance forces are going to equal 0, the net force. That's the only time you're not going to include an arrow, and they cause no movement or no change, okay? If we're talking about something here on Earth, that means the object is going to be perfectly still. If we're talking about something out in space, it will continue to move forever and ever and ever without changing its movement, okay? Hopefully that makes sense. If not, let me know. I can help maybe give you some better examples or we can talk a little bit more. right, the next thing we're going to talk about is what about when objects do move? And we say that when objects move, those are unbalanced forces acting on the object. So unbalanced forces cause objects to move. If we have a coffee mug and someone comes and pushes the coffee mug with a force of 15 newtons, the coffee mug is going to move in this direction now. And we can say that the net force is 15 newtons. But I'm not done. I need to make sure I include my direction. So 15 newtons in what direction? This direction, or we can say 15 newtons west, which is a lot more specific, right? So had nothing come and acted on that coffee mug would be perfectly still. And we can say that the forces are balanced because it's not moving. But because something came and pushed the coffee mug, now the coffee mug is moving. We have unbalanced forces, and the net force is 15 newtons west. Okay, hopefully that kind of clarifies a little bit more. Another example is, let's say you have a box. You have a force acting on it with 20 newtons in this direction, and another force acting on it with 25 newtons in the opposite direction. Now, this becomes a who's going to win, right? This one's 20, this one's 25. Which one's stronger? This guy. So since this guy is stronger, which direction is the box going to move in? It's going to go this direction. How do I calculate the net force? They're working against each other. I'm going to do 25 minus 20 is equal to 5. But I am not done. Because the forces are unbalanced and we get some movement, we have to show the direction. Which way is it going? It's going 5 newtons in this direction, or I can say east. Okay? Remember, force is a vector. It's going to include size and direction. Always include your direction, not just your number. It has to have both. The only time that you don't have both is when you're talking about balanced forces. In this case, you just have the size, which is 0. Okay, guys, so that's pretty much it with these balanced and unbalanced forces. I highly recommend you take these notes, rewrite them so that you remember them better, and take care of yourself. And hopefully this will all be done pretty quickly and we can see each other again. Take care.